is Hrishi Ballal from the University College London. And again, Hrishi is the author of the geodesignstudy.com software, and so I asked him to talk about the architecture of the system. Hrishi.
Well, thank you very much, everybody. Thanks, Tim, for the opportunity to come here and present some of this work. Today, I'm going to talk a little bit about the back end and how I went about building the software that we used in the past 2 days. A little bit of a background about me. I am a mechanical engineer, and I'm not a planner or architect or in the urban planning field. So I came at geodesign from a mechanical engineering perspective. And that fits in very nicely with some of the systems thinking that underpins some of these things. So with that bit of a background, I approached, when I started my research, I was interested in design, and I have a master's in engineering design. And so when I looked at design tools and the way design functions in an urban planning world, you have a lot of tools for data and data management, data manipulation. That's ArcGIS, QGIS. The data side I felt that was very well addressed. And on the other hand, you have good visualization tools now, City Engine and 3D kind of visualization tools. But I did not find a good tool for design, and particularly at a scale when the problems are very complex and you have a number of systems at play, which is usually the case at these things. So that's the kind of the problem that I started to solve when I was approaching this. Specific to geodesign, I approached it from a workflow point of view. What is the process of design creation? And that was my interest. And in literature, there are some kind of papers who I thought were quite relevant to this. And Jack Angerman says that one of the characteristics of geodesign is the short time frame for design creation. Mike Flaxman talks about sketching and quick impacts of those sketches. Carl, in his framework, talks about the fact that it's actually non-linear. And that's what something we experienced the 2 days. It's not a linear process. You have to go back and forth quite a bit to come to a design. And finally, Eduardo, in his paper, says that analytical assessments are required at every stage of a design. And he contrasts actually to the traditional design process where the artifact is created and then analyzed and then kind of, edited. And I think that what he says is that what makes geodesign different is the real-time aspect of analysis with the design. And so it's with this kind of backdrop I approached the geodesign process. Of course, Mike and Carl advised me, so I'm very biased to Carl's framework. So that's the caveat. But we've seen this before. And my journey in the geodesign side started with an analog workshop. And what I'm going to do is I'm going to explain this analog workshop and then explain my thinking behind converting this analog workshop into a digital format and the kind of the back-end structures that were required. And then I'm going to end a little bit with what the future is and what I think is some of the interesting areas for research. So we conducted a workshop. It was done all on pen and paper, and it was in Lisbon. So that's a map of Lisbon. Lisbon's up on the north, and then there is the southern kind of towns, and that's the Tagus River and the estuary. Lisbon, obviously, is the capital of Portugal. And this is an interesting area because it is one of the big commercial centers in Portugal, and also it is in this area that Vasco da Gama kind of started sail to find the New World in the Portuguese Age of Discovery. So there is a huge tension from economic development point of view and the cultural heritage and preserving that. And so I'm hoping that you see how this process works in an analog format and kind of the key elements that are there. So this is a base map on a transparency that was used. You see the simple grid there to manage the diagrams. In the workshop on the first day, all the evaluations were drawn by hand. And here you see simple red and green sketches that were drawn in the first morning for the 10 systems at that time. Then once the evaluations were drawn, we draw the change diagrams also on transparencies and laid out on the table, and the 10 systems are here. And all of this is done on color-coded pens, and there are 20, 30 people who do this. And this is the kind of a view of the 10 systems and some of the sketches that were drawn. Once they're laid out on the table, you are kind of open to see all of the diagrams that are coming in. And this is, again, maybe in the middle of the first or the second day. And you draw the decision models by sketching as well. And then this is an analog process of synthesis, and that's me there. You actually go over to each and every one of these diagrams, and then you select the transparencies and the ones that you like. And that's Eduardo there. And you select the one, and then you actually send it to test to take a picture, and that's your design. Now, these are the kind of designs that you see, descriptions, some legend of what design it is. And this is another example design, and these are the 6 designs that that came about. So I actually studied this from an industrial engineering point of view, where what are the actions that people perform to get to this design, and that's the analysis, and then you do it again. So what I did was I said, what are the actions that people perform to come to this design? And I did it from an industrial engineering time and action study, essentially. And it's for somebody who's interested, I'm not going to ask you to read my thesis, but it's chapter 4. There is a detailed specification for a software of how do you convert a design process as a software interface. So it might be interesting for the people here. So what is the sequence of events? And this is something that Mary and others will be very familiar with. You start with the project setup phase. You then kind of build your evaluation maps. Then you draw the change models. Then the team builds a decision model and creates a synthesis. And then you compare and you do and repeat this process. And of course, that's what it looks like. You kind of go back and forth quite a bit. So what I did was, I took the same model and then I converted it into user actions. So what are the people doing as they go through this process of geodesign or creation of a design? I say they identify the requirements, they set the change teams, you discuss the models, you build the change diagrams and compare designs. And now these individual actions were then converted into back-end and front-end features for the tool. And I'm going to talk about the back-end a little bit and then the front-end for the tool. So in the initial setup, you identify requirements and set up the change teams. So that means that in the database, you need to have a requirements object, a change team object. When the models are being created, you need to have a storage and a data management kind of a module. And in addition, for the sketching that you saw, you need a sketching module. In addition, you need an analysis and a diagrams module that kind of organizes all of this. So here you have some of the underpinnings of the back end of what enables some of this workflow. You have a users module, which is not very dissimilar from the Professor Goodchild's work right now. You have the requirements object, which has things like targets, the type of requirement, the color, for example, of what that requirement is. You have a change team object, which is kind of tied to the users module, where users have to be tied to a change team, and it also has a conductor and participant type hierarchy. And then there is a data management module, which actually handles all the data that is being built. And underpinning the fast design creation and quick iteration is a version control kind of software. And this is indeed what's at the back of Geodesign study. The reason why you can create versions very quickly is because we use Git or Mercurial in this case, traditional software version control systems to manage multiple versions very quickly. I had given a talk on how version control can be used for geospatial data in the Esri Geodesign Summit in 2014, and I can share that with you guys. But essentially what that does is that once you have spatial files in version control, you can do all modern software version control operations such as diffs and merges and pulls and all of that into it. So if you have a shapefile and a polygon in one version, and you can do a diff on what's different in the second version very, very effectively. And modern version control is very evolved to do these kind of things in a routine way. And finally, you need to have an analysis module at the back. In the same way, you have the front-end features that can be extrapolated from the process. People have to add a requirement. The administrator has to add a requirement. Add users to team, which was what I was doing yesterday. Ability to import external data. We had turned it off yesterday, but the data started as shapeclouds from John. The ability to add a diagram, insert into a diagram. So what has happened now is we have studied a process that was done analog and then extrapolated the back actions and the front-end actions. And from a user interface point of view, it's actually quite simple. I found this diagram to be quite powerful, where the entire project data is in front of you, and that's what you see on the screen as well, where we have this big grid of all the diagrams. And then these are the key actions, where you have to re-rank, synthesize, analyze, and draw inside a diagram. So here's how it looks like. So in the front end, I think you should have a diagrams page and a compare page that enables you to do the actions that were identified earlier. And in the back end, you have a data management, spatial analysis kind of module, and a project management module. I actually chose to do it online because I think that was the harder problem, because when you do it online, you get to do the data sync problem, which is a major problem actually. Syncing data across the internet is much more difficult than doing it in a smaller kind of offline way. I want to talk a little bit about the technology stack for the people who are interested here. The server works on Django. The spatial analysis is done by Shapely, which is a Python library for geospatial analysis. The data format is Geodesign. It's a standardized format. It works very nicely over the internet because you're just sending JSON data. And with photobuf and all of that, you can do very, very effective encoding of the data. So the data size is small. And as I mentioned, the version control is the one that enables all of the version creation. And in the browser, the grid is live, as some of you saw. So it's using a lot of WebSockets and HTML5 to connect in a decentralized way all the people who join the project. So what that means is that the analysis is done on the person's computer, and the server is actually free. And then CouchDB is essentially a JSON store, which stores all the JSON data that is generated, and then it just syncs with the individual in the browser. And Turf.js is a new, fairly new library from Mapbox, and it uses JavaScript topology suite, which is again a JavaScript version of Java topology suite, and that's what does the interactions on the browser. What that means is essentially that you're performing GIS operations on the browser, and you don't need a server or any GIS software for it. And I would really recommend looking at Turf.js from Mapbox. They're really very aggressively developing it as a JavaScript GIS engine. I can talk a lot about this, but I really wanted to discuss a few things that are on the top of my mind from future research in this area. The first thing is smart diagramming, and I think we all understand the limitations of 2D sketching in a kind of a compressed time frame. I think that is not designed for course, but I think that there is a huge work to be done on smart diagramming, and I wanted to highlight something here. So this is one of the designs from the analog workshop, and watch these diagrams. So you have these arrows over here. Now imagine if you can have an artificial intelligence or some kind of intelligence embedded into the geodesign process that actually says, well, maybe this boat needs to move somewhere, or this land use needs to extend. So it is these type of smart diagrams that could be drawn using simple, fairly simple kind of objects, arrows, maybe, that can be really a topic of research, and people actually do that very, very routinely. You draw something and you draw an arrow, you kind of say compress this or extend this or join that, and that kind of stuff can be done very effectively. The second aspect that I think we really need to research, and this is something that I'm very interested in, is linking to dynamic models. And there is a huge issue around model interoperability. And when we have 10 systems from different domains, it is practically impossible to get a standard model for anything. And that's why we settle to shapefiles and Geodesign. But really, it's a huge issue for academia and for people outside. This interoperability, I think, is something that this forum, I think, should address for sure, because it is in the domain of geodesign and cyber GIS. And in order to enable more people to get into this, we need to have an interoperable models and have at least a standard where, just like REST or some other web standard, that you can actually query these models and get response from them. The other thing that we actually tried was crowdsourced design, and this is actually quite interesting. 3 weeks ago or 4 weeks ago, we did this kind of a workshop in Sheffield, and over there, almost 90 students joined on their browser and they created a design. So every student created their own design. So you can imagine with this kind of technology, you can have, let's say, an entire town creating their own design, and because it's all digital, you can do all sorts of analysis on it, in the sense that you can have a popularity contest, you can choose diagrams being selected. So I think that this is something that needs to be researched a little bit more as to how effective some of these techniques are for design creation.
That was 90?
Yeah, 90 students simultaneously. But I think it's an interesting topic of research and quite relevant with the age of Kickstarter and all of that. Would this work? I think that's something that needs to be researched. The other thing that I'm quite keen on researching as well is design and data for environments. I think that we are lucky to have tons of data, but there are many problems in many areas where data is not available or is of poor quality. Would something like this work there? Would a quick and dirty design work in those environments? And I think this has a lot of implications for disaster management, for developing countries. And I think this is something that needs to be researched as a topic. And finally, the last thing, I think, because it is digital, I think there are huge implications for artificial intelligence doing these designs in conjunction with people, not maybe on its own as well. We already have demonstrated some baby steps in this. You build a design selecting the sketches which are the least impact or are the most least cost. So there are implications where you can do artificial intelligence research into some of this. As far as the future of the project is concerned, I'm hoping, like Mike said, to graduate in June, depending on Mike Batty and James. But the idea is to make this open and free to access after June. It's going to be called Geodesign Hub. It will be open for everybody to join, and if anybody wants to do a geodesign project, we will provide documentation and manuals to do this. There will be an API support for plugins, so if anybody is interested, they can build plugins for this. And I'm quite open to collaboration on different projects. So that's really like an open invitation for anybody who wants to, is interested in doing any sort of collaboration. I think there are some interesting things that can be done. This is all baby steps. I think from a broader perspective, we are just starting on this journey, so it's a long way ahead. And that's it.
Thank you, Hrishi.